Hello everyone, welcome to COE101 class, Calculus 1 for Engineers. So today we're going to discuss about the very first topic in our course outline. Of course, before we proceed with the discussion of the limits, the functions, derivatives, and other differentiation formulas, of course we have to talk about the review of the pre-calculus subjects like college algebra and trigonometry. That's why in this video, we will be talking about there you go. Review of algebra. Okay. But before that, let me share to you this quotation for today. Yeah, mistakes are proof that you are trying. This is really applicable, especially in this math subject, in calculus subject, since when we are solving math problems, we are prone to mistakes, no? Like the positive, negative sign, baba, when simplifying expression. So those things, like simple mistakes, can make our final answer wrong, but those mistakes are proof that you are trying, unlike those people that didn't try at all, those that are waiting for their classmates, for their friends to just finish their work and you just copy from top to bottom. No, not really recommended. If you really want to know something or to learn something, you have to study it yourself. You have to apply those formulas yourself in order for you to familiarize yourself with all those problems. So the next time you encounter those problems, it will not be very difficult for you. Okay? So yeah, mistakes are proof that you are trying. And all problems have their own solutions. So you just have to try and practice and practice. That's it. Okay? So learning outcome. So by the end of this module, the student should be able to, of course, review basic arithmetic operations, review the division of algebraic expression, review exponential and logarithmic equation, review different operations and their inverses, and how to manipulate formula and solve equations. Okay. So algebra, of course, actually didn't I don't need to define this one because everyone knows what algebra is, right? It's one of the broad parts of mathematics together with number theory, geometry, and analysis. In its most general form, algebra is the study of mathematical symbols and the rules for manipulating these symbols, unifying thread of almost all of mathematics. That's from Wikipedia. Okay, so um, since this is review, I included here a 10-item pre-check that just to recall all those things that we have studied in our algebra class. So let's solve it. Okay, there's my pen. Oh, there you are. So number one, we have 1/2 multiplied by x minus 3 plus x is equal to 17 plus 3 multiplied by 4 minus x. So in this problem, so we have here 1/2, then multiplied by x minus 3. We just have to distribute. So 1/2 x minus 3 over 2 plus x is equal to 17 plus 3 times 4, we have 12 minus 3 times x is equal to negative 3x. Then we combine all the variables in the left side and all the concepts on the right side. So 1/2, we have 1/2 x plus x, then we have negative 3x. When we transpose, it will be positive, so plus 3x is equal to 17 plus 12 plus 3 halves. Okay, so 1/2 x plus x, that's 3 over 2 plus 3. So 3 over 2 plus 3, so that is 9 over 2x. 9 over 2x is equal to 29 plus 3 over 2. And that is 61 over 2. Therefore, our answer is x is equal to, if we cancel the 2 here, we have 61 over 9. Okay? That is our x. For the second problem, we have 5 over x equal to 2 over x minus 3. So we will just apply cross multiplication. So we will be having 5 multiplied by x minus 3 is equal to 2 x. Then distribute 5x minus 15 is equal to 2x. Then 2x, we transpose on the left side, and 15 to the right side. We'll have 3x is equal to 15. Then x is equal to positive 5. Okay. Then for the third problem, we have x squared plus 2x plus 1 over x plus 1 is equal to x plus 1 over x squared minus 3x. So we will just factor this one. X squared plus 2x plus 1 is a perfect square trinomial. So if we factor this one, we will be having x plus 1 multiplied by x plus 1 all over x plus 1. So it's equal to x plus 1 over x squared minus 3x. Let's just factor out x. We will have x minus 3. Okay. Then we can cancel this one and cancel this one. And as you can see, we'll be having 1 here. And I guess there is no need to factor that denominator. So let's x squared minus 3x then equal to 1. Then x squared minus 3x minus 1 is equal to 0. So, is there a factor for this? I don't think so. So let's just use the quadratic formula, negative b plus or minus square root of b squared minus 4ac over 2a. So negative multiplied, this is a, b, and c. Our b is, so I will put the formula here. Our quadratic formula is equal to x equal to negative b plus or minus square root of b squared minus 4ac over 2a. Okay, so this is our formula. So negative b, our b is negative 3. So plus or minus square root of b squared. So that will be negative 3 squared minus 4 times 1 times negative 1. Yan, pardon for my writing. Then 2 multiplied by 1. Okay. So x is equal to 3 plus or minus, that is equal to 9 plus 9 plus 4. 9 plus 4 is 13 all over 2. And that is our answer. Oh, there you are. So that's the x. Next. So in this problem, it's just cross multiplication again. So we will have 8 multiplied by x squared minus 1 is equal to x plus 1 multiplied by x plus 5. So we have, x squared minus 1 is equal to x plus 1, x minus 1, right? So we can actually cancel the x plus 1 here. There you go. So we will be having 8x minus 8. So I distributed already the 8 and then x plus 5. So 8x minus x is equal to 7x. Then 5 plus 8 is 13. So x is equal to 13 over 7. There you go. Now, for question number 5, determine x raised to 4 plus 1 over x raised to 4 if x equal to 2 minus 1 all over 2 minus 1 all over 2 minus 1 all over, and so on and so forth. So, how are we going to answer this kind of problem? So, as you can see, if we will just obey this logic, x is equal to 2 minus 1 over 2 minus. So, we can say that this all is also equal to x, right? So, if we will rewrite that, x is equal to 2 minus 1 over x. Okay? So, let's just transpose the x on the left side. So, we have x minus 1 over x equal to 2. Then, x squared minus 1 is equal to 2x. So, I just multiplied the both sides by x. That's why I get this one. So, x squared minus 2x minus 1 is equal to 0. And then what is this? I mean, this is positive. Oh my God. This is positive. Ayan. So, I made a mistake. X squared minus 2x. X squared minus 2x plus 1. Let me erase that 1. Ayan. So, mistakes are proof that we are trying. X squared plus 1, then x squared minus 2x plus 1, and then there you go. So if we will factor this one, this is already x minus 1, quantity squared is equal to 0. Therefore, x is equal to 1. Okay, there you go. Plus or minus 1. So we were looking for x raised to 4 plus 1 over x raised to 4. So if we will just substitute that, the value of x raised to 4. So we will be computing 1 raised to 4 plus 1 over 1 raised to 4. And that is equal to 2, of course. There you are. Okay. So next we have 4x squared plus 11x minus 3 is equal to 0. So does it have a factor? Yes. So we can factor this as 4x. Then we put x here, then 3 and 1. So 4 times 3 is 12. So since the middle term is positive, let's put that as positive. Then this is negative because 4 times 3 is positive 12 minus 1 is 11x. Then negative 1 times 3 is negative 3. And we equate this as 0. So we have 4x minus 1 is equal to 0. S is equal to 1/4. Then x plus 3 is equal to 0. X equal to negative 3. Okay. Then for next number, so as you can see, this is an application of logarithmic function, and both sides has logarithm of to the base 4. So we can just disregard it, and we equate x squared minus 2x to 5x minus 12. So we will be having x squared minus 7x plus 12 is equal to 0. Factoring this out, we will have x minus 3 and x minus 4, right? Because negative 3 plus negative 4 is negative 7. And negative 3 times negative 4 is positive 12. So that is equal to 0. Then x minus 3 equal to 0, x equal to 3. Then x minus 4 is equal to 0. Therefore, x equal to positive 4. Then for next number, we will apply here the rules of logarithm. Since we have here a negative sign, so that means we have to divide 6x by 4 minus x. So we put logarithm of 6x over 4 minus x equal to 3. I mean, logarithm of 3. And there you go. So this is logarithm of 3. Then we will disregard this since both has logarithm to the base 10. So let's tag dito. Cross multiply. So 6x is equal to 3 multiplied by 4 minus x. 6x is equal to 12 minus 3x. Then let's transpose 3x on the left side. We will be having this is not 16, this is 12. So sorry. At least mistakes are proof that we are trying. So this is 12. 6x plus 3x, that's 9x equal to 12. Therefore, x equal to 4 over 3. There you go. Then, for number 9, this is just converting logarithmic function to exponential function. So, logarithm of 25 minus x squared to the base 3 is equal to true. That's just the same as 3 squared is equal to 25 minus x squared. And that is x squared is equal to 25 minus 9, that is 16. Therefore, x is equal to plus or minus 4. There. Then for the last number, so simplifying this, expression. We'll just apply the rules of exponent. So let's just simplify the exponents inside the parentheses. So let's write 4, then z raised to 12 minus 9, y raised to negative 1 minus 4, then x raised to negative 3 minus negative 8 raised to negative 4. That's why we will be having 4. Z raised to 12 minus 9 is 3. Y raised to negative 1 minus 4 is negative 5. Then x raised to negative 3 plus 8 is positive 5. Then raised to negative 4. So we will have 4 z raised to negative 12, y raised to 20, and x raised to negative 20. So simplifying this one, we'll be having 4 y raised to 20 all over x raised to 20, z raised to 12. That's it. So now we're done with the pre-check. So let's proceed with the first topic, the PEMDAS, of course, the acronym for the words parenthesis, exponent, multiplication, division, addition, and subtraction. So this is the very basic in algebra. Okay. Then, so example, so we have 5 plus x cubed, where x is equal to 2. So 5 plus 2 raised to 3. So when we substitute 2 in the x here, so of course we will just simplify first the exponent 3. So 2 cubed is equal to 8. So 5 plus 8 is equal to 13. Now if we have 5 plus x raised to 3, where x is equal to 2, so of course we will just substitute first the x, which is 2. Then perform addition. So 5 plus 2, 7. Then raised to 3. Then that is 343. Next, we have 6 over x plus 3, where x is equal to 3. So substituting the value of x again in the denominator. So of course, we will just perform first the division. So 6 divided by 3, 2 before we add to 3. So that is 5. Then we have 6 over x plus 3. So here, we will perform first the addition. So x plus 3 first before we do the division, 6 over 6. That's why we come up with the answer 1. Okay? Then we have 8 minus x plus 2, where x is equal to 3. So in this case, we have to evaluate the negative operation first. Negative and positive have the same precedence, but we should compute from left to right. Okay, so 8 minus 3, then plus 2. So we have 5 plus 2. That is 7. However, if we have a parenthesis, so we have 8 minus parenthesis x plus 2, so where x is equal to 3. Of course, we will compute first the operation inside the parenthesis. So 3 plus 2, then 5, and we have 3. Okay? Next is indices or power. So what is an exponent? So the base a raised to the power of n is equal to the multiplication of a, n times, so a raised to n, so that is equal to a multiplied by itself, where n is the number of times that number is multiplied by itself. So example, we have 3 raised to 1, that's equal to 3. 3 squared, that's 3 times 3 is equal to 9, and so on and so forth. So we have here some rules of exponents. So any number raised to 0 is equal to 1. Then, if we have a negative exponent like a raised to negative n, so that is equal to 1 over a raised to n. And 1 over a raised to negative n, of course, if we will put the negative exponent in the numerator, so magiging positive na yung ating exponent. Then we have a raised to 1/2. That's equal to the radical square root of a. And a raised to 1 over m. That's equal to nth root of a. Now, if we will multiply a raised to n by a raised to m, so that's just simply adding their exponent n plus m. Okay? Then for division, a raised to n over a raised to m. So a raised to n minus m. So subtraction naman. Then if we raise a raised to n by m, so like what we did in the previous slide, so we just only have to multiply n by m. So we have a raised to mn. Then, if we have two variables inside the parentheses and it is raised by m, so we just distribute the m. So we have a raised to m multiplied by b raised to m. Same way if they are in division, so a over b raised to m, that's equal to a raised to m over b raised to m. Okay? Example, so simplify 15x multiplied by y, z squared raised to 3 all over 3, x raised to 4, y squared, z raised to 8. So in this case, let's just uh, simplify first the parentheses, what's inside the parentheses. So 15x, then let's just distribute the exponent y cube, z 2 times 3 is equal to 6. Then all over 3x raised to 4, y squared, z raised to 8. Then let's proceed with the division. Applying the rules of exponent, 15 divided by 3, 5. Then x raised to 1 minus 4, y raised to 3 minus 2, then z raised to 6 minus 8. So we have 5, x raised to negative 3, then y, 3 minus 2 is 1, so it's okay not to write the exponent 1. Then z raised to negative 2. 6 minus 8 is negative 2. So simplifying this, we have 5y over x cubed z squared. Yeah, there you go. Next, expand 3x squared plus 7y squared multiplied by 5x squared minus 6y squared. So in this problem, we will just use the FOIL method. So multiplying the first term. So 3x squared multiplied by 5x squared, we have 15 x raised to 4. Then outer, so 3 times negative 6 is negative 18 x squared y squared. Then inner, so 7 times 5, that's 35 x squared y squared. Then last, negative 42 y raised to 4. Then let's just simplify. We have 15 x raised to 4, negative 18 plus 35, that is positive 17 x squared y squared minus 42 y raised to 4. And that is our answer. Okay. So next, expand x plus 4y squared raised to 3. So in this example, we're going to use the Pascal's triangle binomial expansion. Okay. So since it is raised to 3, so we're going to use 1, in our Pascal's triangle is 1, 1, 1, then 1, 2, 1, then 1, 3, 3, 1. So this is raised to 3. So we're going to use this this pattern. Okay, so let's write 1, then x raised to 3 plus x squared multiplied by 4y squared, and of course the 3, so let's put the 3 here, plus 3 multiplied by x raised to 1, 4y squared raised to 2, plus 1 multiplied by 4y squared raised to 3. So simplifying this, we will be having x cubed plus 3 times 4, that is 12, x squared y squared plus 3 times 4 squared, that is 16 times 3, that's 48, x y raised to 4. Then 4 cube is 4 times 4 times 4, that's 64. So y raised to 6. And that is our answer. Yeah, there you go. So what we have used in the last example is the Pascal's triangle. So it's a triangular array constructed by summing adjacent elements in preceding rows. It contains the values of each binomial coefficient. So it is named after the 17th century French mathematician Blaise Pascal. Okay, so this is the Pascal's triangle. Now let's proceed with the common mistakes people do or students do when solving problems. So for example, this one we have quantity 2x raised to 3. So nangyayari, it became 2x cubed. So they forgot that 2 should be raised to 3. So correct is 2 cube x cube, and that is equal to 8x cube. Okay? Another one, if x plus y is raised to 2, so some students forgot the middle term, the 2xy. So this one. Okay? So always remember that x plus y, this expression is equivalent to x plus y multiplied by x plus y. That's why it will be x squared plus 2xy plus y squared if you will apply the FOIL method. Okay? Then, a plus b all over c plus d. So, another common mistake that students do is this one, separating the exponent even if there is a plus sign in the denominator. The, um, in the denominator. So, they separate c and d like this one. While in reality, or the correct form is that a plus b all over c plus d, that's equal to a all over c plus d, plus b all over c plus d. Okay? Then, for a multiplied by bc, so another mistake is that a is being distributed in b and c. See, the correct form is, of course, if a is separated by bc by parenthesis, so that's just a, b, c. So they are just multiplied with one another. Then, if we have the expression a raised to m plus n, so some students do is it is equal to a raised to m plus a raised to n, and that is wrong. So, okay? So, if we have a raised to m plus n, that means a raised to m multiplied by a raised to n. Okay? Then, oh, it's cut. So, 1 over 2 x cubed is equal to 2 x raised to negative 3. So, that's the mistake students do. So, of course, the correct form is that if we will just, if we will put this in the numerator, so that would be 1 half x raised to negative 3. Okay? The 2, or this part, this is constant, so it should still be 1 half and not 2. Okay? Next, division of algebraic expressions. So providing the denominator of a division contains no plus or minus. The division itself is usually straightforward to carry out. Okay, so let's consider this example. 4a cubed minus 10a squared plus 6a all over 2a. So we can separate this, the numerator. You can separate this expression as 4a cubed all over 2a minus 10a squared over 2a plus 6a over 2a. Then, we can simplify. 4 divided by 2, that is 2. A cubed divided by a, so a, 3 minus 1 is 2. Minus 10 divided by 2, that is 5. A squared divided by a, that is a. Then, 6a divided by 2a, so cancel the a, we have 3. So that is our answer. So in our next example, so it's just the same. We can separate the numerator 8x raised to 4y cubed over 2x minus 8x squared over 2x plus 16x over 2x. Then we can simplify 8 divided by 2, that is 4. Then x raised to 4 over x, that is x cubed. Then y cubed minus 8 divided by 2, that is 4x. Plus 16x divided by 2x, that is 8. And that is our answer. Then we have exponential functions and logarithms. So if we have n is equal to a raised to x, then the power is defined to be the base a, logarithm of n. So it is the same as writing x is equal to logarithm of n to the base a. And we have here three rules of logarithm. So if we have logarithm of r s to the base a, so that is also the same with logarithm of r to the base a plus. So note the plus here, so logarithm of s to the base a. Then if we have r over s, so the same, but this is minus. So logarithm of r to the base a minus logarithm of s to the base a. Then if we have logarithm of r raised to n, so we can put the exponent n here. So we have n logarithm of r to the base a. Okay, so that is the rules of logarithm. Now, example, if we expand this one, logarithm of x cubed y raised to 4 over z squared. So let's just apply the rules of logarithm. Logarithm of x cubed plus logarithm of y raised to 4 minus logarithm of z squared. Yan. Since this is negative. And then we apply the exponent. This is 3 logarithm of x plus 4 logarithm of y. Then this one is 2 logarithm of z. And that's it. Next is write 4 ln of x plus 6 ln of y plus z minus 3 ln of y as a single logarithm. So this ln here is a natural logarithm. So it's the same as putting or writing logarithm to the base 10. So that's the natural logarithm. Okay. So simplifying this one, 4 ln of x. So we can write this as ln of x raised to 4. Then this one as ln of y plus z raised to 6. Then this one as y raised to 3. Then putting it in a single logarithm, we will be having x raised to 4, y plus z raised to 6 all over y cubed. And so this is our answer. And there you go. Then we have here operations and their inverses. So for example, we have plus a, x plus a, inverse is negative a to find x. If we have x minus a, so we just have to add a again to have the x. If we have ax, so divide both sides by a to have the x. If we have x over a, so multiplied by a to have the x. So that's just inverse operations. So if we have here, for example, 10, logarithm of 10, logarithm of x to the base 10, so that's x. Then we have here an exponential function raised to ln of x, so e raised to ln of x, so that is equal to x because exponential and logarithmic are inverse. Then that's just the same with ln of e raised to x. Okay, so that's also x. Then we also have here inverse trigonometric function, the rx sine of sine x. So of course that is also x. Okay. So in manipulating formula, one will need to use the above operation and their inverses. So the one that we had discussed in the previous slide, we're going to use those functions in manipulating formulas and equations. So for example, we have here an equation y is equal to 2e raised to x, so solve for x. So let's rewrite the equation first. Y is equal to 2e raised to x. Then to solve for x, we have to divide both sides by 2. So y over 2 is equal to e raised to x. Now to cancel this e, so this is an exponential function, so we have to use the logarithmic function, which is the inverse of exponential function. So now we will have x is equal to ln of y over 2. This is y. Yeah, this is y. And that is our answer. Now determine t when 10 raised to 0.5t is equal to 8. So how are we gonna solve this one? So we can use logarithm on both sides. So let's put logarithm on the both sides or ln. So that's just the same. Logarithm of 10, 0.5t is equal to logarithm of 8. Then we put this exponent here. So 0.5t logarithm of 10 is equal to logarithm of 8. So to solve for t, we have to divide both sides by 0.5 logarithm of 10. So t is equal to logarithm of 8 all over 0.5 logarithm of 10. Or that is 2 logarithm of 8 all over logarithm of 10. That's it. Or it's also equal to 2 ln of 8 all over ln of 10. So that's just the same. Yeah. Oh, and that's the end of our topic for today. If you have some questions, feel free to comment on the comment box below. Okay, so have a good day.